Hello dear students, how are you? I think you are all very fine. And now today in this class we are about to study the derivation of the equation of motion by theoretical method. Actually, equation of motion what is? So I want to say to you, actually when any body moves in a straight line with uniform acceleration, okay, then the relation between velocity, time, covered distance and acceleration is called equation of motion. That is 3 in numbers. What is v equals u plus at, s equals u t plus half at square, and v square equals u square plus 2a s. Okay, actually my dear students, here v is final velocity and u equals initial velocity of object, a equals acceleration of object, s equal displacement by object, and t equals time duration during velocity u to v. Okay beta, this is the representative letters. Okay, and now we are about to derive the equation of motion by theoretical method. Now derive the first equation of motion. First equation of motion, that is v equals u plus at. So I want to say to you, what is that beta? Let's any object moving with initial velocity u and acceleration is a. After t time, velocity will be v. Then we know acceleration is called change in velocity and time period. So now change in velocity v minus u, final velocity minus initial velocity, final velocity minus initial velocity upon time period. Final velocity is v, initial velocity is u upon time period t. Now at equals v minus u, so v equals u plus at. It is the first equation of motion. Then now in vector form, v vector equals u vector plus a vector t. Okay beta. Now we see second equation of motion. Second equation of motion. Okay, what we see, that is s equals ut plus half at square. So let's consider an object moving with initial velocity u undergoing uniform acceleration a after t timing final velocity will be v. So I want to say to you, what is acceleration? What is acceleration? Change in velocity in 1 second. Actually, a is change in velocity in 1 second. So velocity, what is velocity of object after 1 second, after 1 second from starting the motion is u plus a. Actually, initial velocity at timing t is equal to 0, that is a u. So after 1 second velocity increases by a. So after 1 second the velocity is u plus a. Now velocity of object before the 1 second just before end of motion is v minus a. Actually, you have to understand, when motion is about to end, just before 1 second the velocity is v minus a. Now average velocity of object is u plus a plus v minus a upon 2. It will be cancelled out. So v plus u upon 2. It is the average velocity of object. Okay. Now once again I will see. Dear student, just a way similar to this, we say after 2 seconds the velocity of object from starting the motion is u plus 2a. In 2 second velocity increases 2a, so add in u. Before 2 second the velocity of object, this is from end of the motion. When motion is about to last at that point, before 2 seconds just, the velocity is v minus 2v. So average velocity v minus 2a u plus 2a upon 2 v plus u upon 2. Actually the average velocity is same at every time. Average velocity is same, not change. So we say what? That acceleration is constant. Acceleration is constant. So we can say that object moving during total time with constant average velocity, that is v plus u upon 2. Now we consider, so object moving with constant average velocity during total timing t. Okay, whole the time object's velocity is constant, not change. So what we will say? So we will say that distance or total displacement of object is average velocity multi timing. Okay, let's see. Now S equals average velocity v plus u upon 2 multi timing is what beta? T. Okay, so that's I shown you, यही तो होगा. So that beta, my dear students, we put up the value of v equals u plus at plus u into t upon 2. Now my dear student, 2u plus at upon 2 multi t. Now 2u t plus at square upon 2. That's now right here. 2 to cancel out, here remains ut plus half at square. This is second equation of motion in vector form. S vector is u vector dot t plus half a vector t square. It is second equation of motion. So my dear students, let's see the third equation of motion. Dear students, let's see the third equation of motion. Motion. From the equation number first, v is equal to u plus at, and now v square equals to u square. I'm sorry, on squaring both sides. Now v equals u plus at whole square. Here u square a square t square plus 2u at. A square plus b square plus 2ab. Now I want to say to you, my dear students, what is that? V square is equal to u square. I want to say to you, when I common from here 2a in both, 2a will be common. When I common 2a, now this will be half at square. Actually a common, that remains only 1, and 2 commons means divide by 2, and here 2a common, so ut remains here. And now we write now here v square equals u square. This is, from this equation, is total displacement. So now this is third equation of motion, that is derived by theoretical method. Now write from in vector form, v vector dot v vector equals u vector dot u vector plus 2 a vector dot s vector. This is the equation of motion, third equation of motion. Okay, goodbye.